Hello folks, reporter Jessica Nickel here, coming to you live from Exploration Place's pond, where something very strange has happened. Just take a look. The water, we see it's turned green. Now this looks like some kind of dye to me, but I'm no expert. However, here at Exploration Place, we have those kind of experts, and we are going to be talking with one in just a moment. Her name is Miss Victoria. Over to you, Miss Victoria. What is a dye?
Well, Miss Jessica, in order to solve the mystery, we must first talk about polymers. So when we're talking about dye, we have polymers, which are just really long chains of the same material over and over and over again. And that's what things like our fabrics, like cotton and silk, are made of. So when we have those long chains of polymers, they fold together to create big pieces of fabric. And we get those fabrics like cotton or wool or silk that all bind together, all right? And then we can soak them in something like a washing solution to loosen up those bonds just a little bit so that our chemical from our dye is able to bond to it at a molecular level. So we can then add the dye, and then it will go ahead and stick to different places on our polymer.
Whoa, so polymers are what makes dye stick to things like fabrics? I thought polymers were only in slime. Apparently, they're everywhere. Now, Miss Victoria, this dye is a green color. How come it's not pink or purple or blue? What makes a dye a certain color?
Well, there's many ways we could change our water or even fabric to different colors. And we can do some of that through color mixing with natural dyes. And we can get our dyes from many places. Flowers, insects, or tea are some options. So we're going to start out with some cochineal bugs here. So these are just their shells. And we're going to grind those up in our mortar and pestle. And then I'm going to take my stick here. We're going to put those over here so that we can use them to mix all of our dyes in. And I'm going to give it a good rinse with a little bit of H2O just to get some of that out, so I can do my next one. We can already see that that color has turned rather red. For our next one, we're going to use some butterfly blue pea flower. And we're going to crush those up as well. What color do you think these will turn out? Well, I guess we're going to have to wait and see. There's definitely blue in the name, so we'll see what happens. Well, now that I've given those a good crush, we'll dump those in this one over here. Wind is blowing my stuff around a little bit, so we'll just put those right there. Stick that on top of there. And we'll give this another good rinse, just to get the rest of that out there and see what color we start to get. Ooh, really pretty purple. So now that we have a couple of different colors, let's take a look at how those look on our palette. So we'll take a few of our shells, put those right here. A couple of our flowers, we'll put those right here. And we can use acids or bases to change what that color looks like. So I can take a small amount of my powder and add it to here. And this time I'm going to add some vinegar. I'm going to get an orange color instead of the red color that we got with just water. Mix that around. It's a lot lighter of a color. I can even add some of this in there and watch what happens. It still turns orange. But what happens if I add a base? So I can take a few more of those, put them right in here, and add soda water, which is a base. And what color is that? That color is so different compared to the last color we were seeing. In fact, it's much more purple. So let's see what happens to those flowers when we do the same thing. So we have our purple water right here. That's a much bluer that we got with just the water. Let's add a little vinegar and see what color we get. I can can even crush that around a little bit more. See if I can get some better color out of it. There we go. And it turns pink. Then if we do the same thing, but we add soda water to it, we get blue. So we can mess with the acids and the bases to make different colors. And there's pigments that can be found in anything, including teas. So I can take a pinch of my matcha tea, put it right here in the middle, and that color is already green. So let's see what happens to that when we add some water. Now it turns really green. But let's test it and see if we can come up with a better green for our acids and bases. So we'll start off with the vinegar. And then we'll put the soda over here. And that one doesn't react quite as much, but we still do get some different coloring. You can already see here in the middle that some of those shells got mixed in, and it's turning it a little bit of a brown color. So we can mix even more of those in order to change the color to yellow and a yellowish brown. So we can mix these different types of colors together and those pigments together to get the colors that we want. So for us, we actually used a lot of different greens in a natural dye that we were able to purchase online, which was able to dye the pond green. And water is just like our fabric. It chemically bonds to those different pigments, meaning you can't get the pigments to go away once they're in the water.
Miss Victoria, you just blew my mind. You added acids and bases to the dye color, which caused it to change its own color. How cool is that? So I have a question for you though. Laundry detergent, isn't that a base? Yet we add it to our laundry when we do the wash. How come it doesn't change the color of our fabric?
That's a really great question, Jessica. In fact, the reason that is because those dyes are already chemically bonded to your fabric. So unless you go washing it with different colors, you should be okay, but you might get some fading.
And now that we know that the pond is green and how we can dye it green, I guess that means we should wish you a Happy St. Patrick's Day!